Welcome back, learners. In our previous lecture, we were discussing about the axial columns, uniaxial loaded column and biaxial loaded column. And we have seen that how we are supposed to clearly identify that whether the column has to be designed as an axial loaded or uniaxial loaded or biaxial loaded. Now, the design of uniaxial loaded column we have seen. Now let us see today that the design of the biaxial loaded column. That means, as the name itself indicate, you will be having three loads here. First will be the axial load. Second will be the moment along the longer direction. It may be MUX or MUY. And the moment along the shorter direction. If moment along longer direction, if you are taking as MUX, then moment along longer direction will be taken as MUY. Right? Okay. Now, as usual, let us develop the Excel sheet later, but first we have to understand the biaxial loaded column design, which is little bit very peculiar. First, you will be deciding, as you know, the grade of concrete that you are going to use for the column. You will be deciding the grade of concrete, that is FCK. And initially we will be designing, or we will be assuming the dimension of the column. What we call it as preliminary design we have done. No? Based on the preliminary design, we will be assigning, or we will be assuming the longer dimension of the column. Usually we represent it as capital D. Shorter dimension of the column, usually we represent it as small b. And both will be considering in an mm. This one, that is shorter dimension and longer dimension. Then the axial load on the column we are going to consider, and the axial load on the column that we are going to consider, we consider as the PU value, which will be in kilonewton. Okay, that is axial load on the column, it will be in kilonewton. Okay, that is axial load on the column, which will be in kilonewton. As I already told you, since it is an biaxial loaded column, along with the axial load, you will be having two more moments. Moments along the moment at the base along the longer direction. I can take this as m suffix ux, or I can take m suffix uy, nothing wrong. It is all left to us how we are going to take. Okay, if you are taking along longer direction as MUX, then you take shorter dimension as MUY, or vice versa. Okay, so according to that, I am going to take the moment along the longer direction as MUX value that we are going to obtain from the software, which will be in kilonewton meter. Then next you have the moment along the shorter direction. So we have taken it as MUY. Okay, or it can be taken as vice versa also. That is also, and it is an input value which will be in kilonewton meter. Right? Okay. Now, once you have these three values, then assume the effective cover to the column, that is D dash. Now here you are supposed to find out the D dash value two times. You can see here, if you see the design of the uniaxial loaded column, based on how the column is going to bend, according to that your D dash value, your D value used to be considered. That is, if it is bending along the longer direction, then you will be taking the D as the longer dimension of the column, that is D dash by longer dimension of the column. If the column is bending along the shorter dimension of the column, then you will be taking D dash by shorter dimension of the column. But that means you are going to take any one value based on the bending of the column. Since here bending is present in both the direction, so we are supposed to take the D dash by D value twice. That is, one will be D dash by shorter dimension of the column, Another one will be the D dash by the longer dimension of the column. Okay, so D dash we are going to consider, that is effective cover. After finding out that effective cover, it will be effective cover divided by the shorter dimension of the column, one value, effective cover by the longer dimension of the column, that is another value. Then before we start seeing the chart, here you are supposed to assume the percentage of steel. From the minimum percentage of steel of 0.8% to the practically possible percentage of steel 4%, you are supposed to assume the percentage of steel. Okay, the percentage of steel I am going to consider as P. Okay, so once I assume the percentage of steel, then you multiply that percentage of steel by the gross area. You will get the percentage in you will get the area of the steel in mm square, and assume the diameter of the one rod. You will get the area of the one rod. So when you divide area of the one rod by total area into 1000, you will get the total number of rods. That is the total percentage of steel by area of the one rod. You will get the number of rods. That means here, if you see the design of axially loaded column, there at the end itself we used to get the percentage of steel, and after getting the percentage of steel we used to calculate the corresponding number of columns, number of rods for the given column. But here we are initially assuming the percentage of steel. Okay, now by knowing the percentage of steel you can find out the P by FCK value. Now you can see that these charts are there, that is from chart 27, okay, chart number 27 to 50, that is based on whether your dimension of the column is rectangular column or circular column, and based on the reinforcement that you are going to provide on only 2 sides, or if you are going to provide on 4 sides, and based on the D dash by D value, that is cover, effective cover by longer by shorter dimension, and based on the grade of steel, that is FI 250 or FE 415 or FE 500. Based on these 25, 27 to 50 charts of SP16, it is going to vary. Now first what I will do is, now I will find out the value of MUX by FCK BD square from P by FCK and PU by FCK BD. Okay, what I will do is, based on the D dash by D value, okay, now I am finding out MUX by FCK BD square. That is, MUX represents, that is the moment of the base along longer direction. That means I am supposed to take effective cover by longer dimension. By looking into the value of effective cover by longer dimension, and by looking into the grade of steel, whether it is 250, 415 or 500, and based on the rectangular column or circular column, and if it is a rectangular, based on the reinforcement on 2 sides or 4 sides, what I will do, I will go to the corresponding chart, like for example like this. So I will be knowing PU by FCK BD value because I know the value of PU, I know the value of FCK, I know the value of B and D, and I know the corresponding P by FCK value because I have assumed the percentage of steel. Since I have assumed the percentage of steel, I can get P by FCK. So from the corresponding PU by FCK and from the corresponding P by FCK, I can get the value which is, we call that as MUX by FCK BD square, which is MUX by FCK BD square. Okay, MUX by FCK BD square. Now once I get MUX by FCK BD square as some value, now I will find out MUX1. How I will find out MUX1? This MUX by FCK BD square value, what you got from this previous step, this value into FCK into B into D square. So when you do that, you are going to get mu x1 value for that corresponding percentage of steel that what you have assumed. Okay, then after that what I'll do, now this is mu x is with respect to the longer dimension, longer moment, okay, along the longer direction. Now similarly you are supposed to find out mu y, that is the moment of the base along the shorter dimension. So that time you are supposed to consider the effective cover by the shorter dimension of the column. So based on effective cover by shorter dimension of the column, based on the Fe415, Fe250 or Fe500 grade of steel, based on the circle or rectangle, based on after finding out rectangles, that is reinforcement on 2 sides or 4 sides. Again I look into the charts. After looking into the charts for that corresponding PU by FCK BD and corresponding P by FCK, again I will get that one more value that I am going to call that as mu y by FCK BD square. Definitely it will change because my D dash by dimension value is changing, because one time I am taking shorter dimension of the column, another one time I am taking longer dimension of the column. So therefore definitely 2 times also your mu x by BD square value and mu y by BD square value is going to vary. So therefore now I am going to get mu y by BD square FCK BD square value. So that value I am going to multiply by the corresponding FCK into B into D square to get mu y1 value. So finally I am going to get mu x1 and mu y1. Once I got the value of mu x1 and mu y1, what I'll do, I'll find out the value mu x by mu x1. Okay, mu x is the value which we have got it from the software, and mu x1 is the value which we got here. Similarly, mu y is the value which we have got from the software, and mu y1 is the value which we have calculated here. So we have find out the value of mu x by mu x1, mu y by mu y1 we have find out, and we have kept it aside. So once this is done, then we have already assumed the longer dimension of the column and the shorter dimension of the column, right? We have already assumed the longer dimension of the column and shorter dimension of the column. Since we have already assumed, let us call that as the gross area of the concrete, which we call it as AG. The gross area of the concrete, which we call it as AG, which is equal to longer dimension into shorter dimension. So once you got this, since we have assumed the percentage of steel, we can get the total area of the steel by multiplying percentage of steel into the dimension of the column. So therefore get the value of 100 AST by AG value. Get the value of 100 AST by AG value. Once you got the 100 AST by AG value, go to chart number 63. Okay, go to chart number 63. Yes, you can see here. You can go to chart number 63. Now in the chart number 63, you have 100 AST by AG value we have already calculated based on whether it is 250, 415 or 500. So cut that corresponding line. So once you cut that, you go down in the again that you have one more value, that is FCK, whether it is 30, 25, 20 or 15. So somewhere it will cut based on the grade of concrete, that whatever you are going to assume. So from that corresponding, when you come into the left side, you are going to get PUZ by AG value. Okay, PUZ by AG value. You are from this chart number 63, finally I'll get PUZ by AG value. So once I get PUZ by AG value, you multiply that value by AG, therefore you will get finally PUZ value. Once I get the PUZ value, get the PU by PUZ value. Once you got PU by PUZ value, now go to chart number 64. In the chart number 64, here these values represents PU by PUZ. So we already have the value of PU by PUZ, right? So now from PU by PUZ and out of MUY1 by MUY by MUY1 or MUX by MUX1, the choice is left to us. If I am choosing MUY by MUY1, then from the value of the MUY by MUY1 what we have got in the previous step to the corresponding PU by PUZ value, when you bring it like this and when you come down, you will get the value of MUX by MUX1. That means from the chart 64 I am going to get MUX by MUX1. This value of MUX by MUX1, what you have obtained from the chart, should be greater than, it should be greater than the value what we calculated MUX by MUX1 here. The value of MUX by MUX1 what we have calculated from the chart should be higher than the value of this MUX by MUX1 what we have calculated. If it is higher, then this indicates that the percentage of steel what we have assumed is proper. If you are getting the value of MUX by MUX1 from the chart lower than MUX by MUX1 what we calculated, then the criteria is not satisfied. Then you have to increase the percentage of steel and you have to redesign it. This is how the procedure that we are supposed to follow when you have the biaxial loaded column. But whatever the procedure we have seen here, it is exactly suitable if you are doing any problem theoretically. But practically, applying this concept and getting the percentage of steel and finally the number of rods which has to be executed in the site is difficult in this manner, because it is like an iteration process. You have to assume the percentage of steel. After assuming the percentage of steel, finally you will come to know whether that percentage of steel what you have assumed is sufficient or not. If you have 1 or 2 or maximum up to 10 columns, then each and every individual column you can design like this by making some iterations. But when you go for high-rise buildings, right, in that case every time you cannot do the iteration and you cannot cross verify and you cannot increase percentage of steel. No. That's why in the next lecture let us learn that there is another method that usually we follow in the practical designs of columns, because when we follow that, by incorporating the effect of both the moments, that is moment along shorter dimension and moment along longer dimension, we calculate the stresses. From the stresses we calculate the corresponding area of the steel required. From the area of the steel required, we finally give the area number of rods required for the column. So that let us learn in the next lecture that how to do the design. After that, let us go to the design of beams. Thank you, learners.